Okay, now members, let us see examples about work specifically before we go to energy and power. Okay, a body of mass 6 kilograms at rest was pulled by a force F at a velocity of 3 meters per second for 4 seconds through a distance S. Find the distance S, acceleration of the body, then work done. Okay, that is our distance in our solution here. And that our distance is equal to speed. Velocity times time. Or because they're giving us velocity, we can use this first equation, the second equation of motion. So in our part A, our S is equal to ut plus a half. Then the other square distance F plus a half a t squared. So see from here, we need the acceleration first. So from there, I say from B equaling to U plus AT. From here you can see that our U is 0 because the body is at rest. Then our V is equal to 3 meters per second. And then our T, from there our T is 4 seconds. So putting here, we have 3 plus the acceleration which we are looking for. Then times 4. And from here, acceleration is going to be 0.75 meters per second. So coming and getting my distance here, my S will be U, which is 0, into 4, then plus a half 0.75 into time, which is 4 the whole square. And so here my distance is going to be 16 divided by 2, so 8 times. This will be giving me 6 meters. Okay, so if this was speed, then you would have handled it otherwise. Anyway, so we have this distance, we have the acceleration, then they are asking us to get the work done. So that our work is equal to force times the distance. So this force is the same as mass times acceleration times S. So our mass was 6, 0.75, then times a distance which is 6. And this is going to be 27. So 27. And we say the SI unit is joules for work done. So that's how we handle that. Okay. Then we count this. A force of magnitude 10 newtons acting in a direction. So the moment they are giving you force and in a direction which it's acting, where that calls for another way of getting that force in terms of the direction. Moves a particle from this to this. So from there, in our solution, so this OA, we convert them into vector forms, -1, 5. Then our OB is going to be 7, 10. So meaning the distance we move, first of all, we need the distance. So our AB, no matter how we get AB, we get OB minus OA. This will be 7, 10 minus OA, -1, 5. And here, the distance AB that is moved from A to B is going to be, that is 8. Then this is going to be 5. So this is the distance we've moved. Now, we need our force. So the F, now the force that this one they are giving us is that I think you can see. Now they are giving us its direction. So, meaning to get F, we shall get then times the unit of that force. Okay, so from here we have the magnitude of this force is this, which is 20. Okay, first of all, but it's going to be given by, this one is given by F over, then we get the magnitude of this force here. simple as that. Okay, so this will give us 20. Okay, it's going to give us 20 over the first, the vector forms, which is the direction. Okay, so that's that. Okay, so to get the unity vector of this, we get the vector, the force of that, the direction of this vector, we get its modulus. That's when we shall get the unity vector. So the first direction of the force was 3I minus 4j, then over the magnitude of this, which will be 3 squared plus -4 squared. And so it's that now our F curve is going to be, this is going to be 1 over 5 into 3I minus 4j. So from here now I can get my F, the vector form of this force. This was the magnitude of this force. But now we want the vector form of this force. We get the magnitude of that vector, then times its unity vector. So now this was 20, then times this is given as into 3I minus 4j. So from here I see that our F is going to be, this is 4 times this will get 12I, then minus 16j. Now this is our force in a vector form. Remember, even the distance is in a vector form, so we need to dot them now. So our F, you can write it as 12 negative 16. So remember our work done, but our work done is equal to force times the distance, which will be now our force times the distance, which is AB. Sorry. Now we are in vector form, so we are just going to dot those two. Times S, dot S, then dot B. Okay. Remember, we can multiply vectors, we just dot them. That's the idea there. So this is our F, which is 12 minus 16, then dot our distance, which is 8, 5. Hope you remember how we dot. We get this times this, then plus this times this. It will be now 12 times 8, then plus negative 16 times 5. Okay, this I think is going to be what? 96? Yeah, 96 minus 80. 96 minus 80, which will give us 116 joules. And that's how that's going to be our work done. So in simple terms, whenever they give you a force, whenever they give you a scale of that force and direction, you always get the vector form of that force by getting that scalar, then times the unity vector of the direction vector they are giving you. So the direction vector of this, the unity vector of this, you get the direction vector over the magnitude of the direction vector. As simple as that. Okay, so let's see this one. A body of mass 12 kilograms. So a body of mass, they are giving us mass as 10 kilograms. Moving through a distance, so they are giving us S as 5 meters. Through a rough, whenever you hear rough plate, you have to expect some friction. So this is now going to be work against friction, because you are applying a force. If a coefficient of friction is, now they are giving us mu as 0.25, I think that is a quarter. Find the work done against gravity. So you said our work done is going to be magnitude of the frictional force, then times the distance. But now our frictional force is going to be magnitude of mu r, then times s. And simple terms, we need mu r s. We need this r. How are we going to get the r? So this is how I'm going to get the r. The body is 12 kilograms, meaning it's going to be having a weight acting on it, which is 12 g. Then here I'm going to be having the reaction between the body and then that rough surface. Okay, so from there, I think you can set my R is equal to 12 g, which will be 12 times 9.8. So my R will be 12 times 9.8. 117.6 newtons. After getting this, come and punch it here. So this one was 0.25 times 117.6, then times 5. So from there, that's where I'm substituting that. So now our work done is going to be minus 5 times 0.25. And the answer is 147. And these are yours. So with easy. Work done is the easiest we are going to handle. Okay, so that's it, members. I wish you well.